6 problems from spring 2024. Let's get it done. Consider the graph. Y equals x squared minus 2x minus 8. Okay, I've considered it. Let L1 be the secant line to this graph through the points where x equals a and x equals 2. Let L2 be the line tangent to the graph at x equals 2. Find the value of a so the lines L1 and L2 are perpendicular. Okay, so we have secant line. Now secant line is saying, we're going to cross at 2 points. And so in particular, when we talk about the slopes, and we're going to be talking about slopes because that comes from perpendicular. Perpendicular means the slopes are negative reciprocals. So L1 is like an average rate of change. So we say, okay, so L1, we're talking average rate of change from x equals a to x equals 2. Now L2 is a tangent line. So now L2, that's an instantaneous rate of change at x equals 2, because it's tangent at 2. And what we need is these need to be perpendicular to each other. Okay, so we need to talk a little bit about average rate of change, we need to talk a little about instantaneous rate of change, and then we have to do some comparisons. Let's start with L1. Average rate of change. Okay, so it's like the slope of the secant line from a to 2. So we say, okay, slope of L1, well, that's going to be f at, let's say 2, subtract f of a over 2 minus a. I don't know how a relates to 2. I don't need to know. All right, well, what's that? Well, f of 2, we plug it in. We get 4 minus 8. Subtract a squared minus 2a minus 8. All of that over 2 minus a. All right, so we have 4 minus 4, that cancels. Minus 8 minus 8, that cancels. So what does that leave us as? Well, upstairs, if you put the minus through, that's 2a minus a squared. Downstairs, that's 2 minus a. Well, you can factor the upstairs, and you say, you can cancel the 2 minus a's, so it's simply a. Oh yeah, a, you betcha a. Oh yeah, sure. Oh yeah, sure a. Okay, now slope of L2. Slope of L2, instantaneous rate of change. So what are we going to need? Well, we're going to look at y prime. So take the derivative, 2x minus 2. Okay, so now we're going to plug in 2. So at x equals 2, we have that y prime is 2 times 2 minus 2, which is 2. Now, we're almost done. These are our slopes. So we need to have that a and 2 need to be perpendicular slopes. So how do you know if two slopes are perpendicular? And you should know this. Good to know. They should be negative reciprocals. So in other words, 2 times a, when you multiply them, you get negative 1. Or, if you like, a is negative 1/2. There we go. All right. Good. Nice start. Number 2. Compute the following limits without using L'Hopital's rule. But what is L'Hopital's rule? Someday we'll talk about it. Now, when you're dealing with limits, what's the first thing you do? The first thing you do, plug it in. You plug it in, and you ask, do I get a number? And if you do, you're done. Do I get 0 over 0? More work. Infinity over infinity, more work, right? But if you get a number, you're done. So you should always plug in first. So plug in 0. Okay, what do we get? Cosine of 0 is 1. Cosine of 0 is 1. Sine of 0 is 0. 1 over 1 minus 0 is 1. Okay, part A is done. And you're probably thinking, that's a suspicious amount of space they left. Well, they didn't want to give away that it was so quick. And they were probably thinking like, I bet you they're going to think of something. So they wanted to trick some people, and I bet you they did. Now, what's the trick? Well, a lot of people might look at this type of problem and say, I have an idea. whenever I see a sign in a limit, I remember this really cool fact, and it's totally cool. It says limit as blah goes to 0, sine of blah over blah is 1. Okay, so if I have sine and I have 0 over 0, I need to pull this fact out. But if I don't have 0 over 0, I don't need to do anything. Life is good. All right, part B. Okay, so again, plug in. Now, you might say, well, what do you mean by plug in infinity? What's happening as you go to infinity? Well, we say big, big, yeah, big, big, yeah. So what's happening is you get infinity over infinity, which is not 1, it's more work. Okay, so how do you deal with infinity over infinity? You say, oh, slow down there, slow down. How do we slow down? We look at the rate of growth. So what's the thing growing fastest, right? What's contributing to the growth? It's these x squared terms. So we say, cool. What we'll do is we're going to rewrite this. We're not going to change it. We're just going to write it in a different way. So we say, let's take this, and we're going to multiply the top and bottom by the growth. So in this case, we're going to multiply top and bottom by 1 over x squared. Now in this case, they both have the same growth. If they had different growths, just pick one or the other. The point is, we need to slow something down. We want to slow it down so it doesn't go off to infinity, doesn't go to 0. We want that sort of sweet spot that's between 0 and infinity. There's a lot of sweet spot to shoot for, but okay, slowing it down, slowing it down. So multiply that 1 over x squared through 3 plus 7 over x minus 3 over x squared, 4 plus 2 over x plus 1 over x squared. And now plug in infinity. Anything, number over big is small. So what do we get? We get 3 plus 0 minus 0. Downstairs 4 plus 0 plus 0. In other words, we slowed it down. Not too much, just enough so that we got numbers and we're done. Now, keep in mind with infinity, know which infinity you're going to. Is it plus infinity or is it minus infinity? Because it makes a difference sometimes. Sometimes it doesn't, but they like to pull it out when it does. So keep that in mind. Keep that in mind. All right, great. Number 3, we're moving right along. Consider the function f of x given by f of x is the square root of 2x plus 1. Using the limit definition of the derivative, find f prime of 4 and f prime of 12. And then like really bold, no credit will be given for derivatives not computed using the limit definition. Ah! So they really are testing us on, do we know the definition and do we know algebra? Okay, now let me talk for a second here before I jump in. Notice that we're asked to find the derivative at points. So we have two options. We can either find the derivative at point 4 and then separately find the derivative at point 12 and then not have to deal with x. Or we can do a generic find the derivative and then plug in 4 and plug in 12. Now because we have to do 2, we'd probably say, look, I'd rather only have to do the limit thing once. If it was just like f prime of 4, I would only say, okay, f prime of 4 is the limit at a particular point, and that makes things a little bit easier. But because it's both, I'm going to say, let me do the generic definition of derivative, and let's figure out what it is. Okay, so it's always going to work the same. I'm after a derivative. So you say, great, write down f prime x equals, and then limit h goes to 0, f of x plus h minus f of x over h. Now where is this coming from? This is the definition. You're going to get points. If all you do is write that down, you're not getting 0. So good. We already know we're not getting 0. Yeah! Way to go us! Okay, but we want more than not 0. We want like lots of points. Okay, now the next step, this is also an important step, is know how to put in x plus h. How do you do it? everywhere you see an x, put in x plus h. And some advice, parentheses, here we're going to make some notes, parentheses equals friends. Right, use your parentheses. So by that, I mean the following. Notice, by the way, you keep writing the limit, don't forget. So we're going to write this as square root 2 parenthesis x plus h plus 1. So if you didn't write it down, just 2x plus just h, you would neglect, oh, that 2 multiplies by that h. Oh, and you'd lost something. And we don't want to lose anything. We want our points, right? We deserve our points. Now, talking algebra. Fractions, got to know how to do fractions. Squaring, or foiling if you like. Got to know how to foil, got to know how to factor. And you got to know how to deal with square roots, because this is a square root one. How do you deal with square roots? Well, you get rid of the square roots. Now you might say, wait, why are we dealing with square roots? So remember, what's our mindset? Our mindset is we say, oh, we currently have a 0 over 0, right? If you plug in h equals 0, it's 0 over 0. So our goal, say, look, we don't want that. So we're going to cancel some zeros. So we're going to cancel some h's. That's our goal. So with that goal in mind, we have to somehow manipulate the expression so we get an h upstairs. We've already got an h downstairs. We just need an h upstairs. See how the h is inside the square root? So we got to do something to get it out of the square root. So, long story short, we have to do something that gets rid of square roots. Not squaring, unfortunately, but conjugation. So, know how to deal with conjugation. All right, 2x plus h plus 1 minus square root 2x plus 1, top and bottom. Okay, I'm sorry, not minus, plus. You flipped the sign. All right, now upstairs, why do we like this? Well, because we have an a minus b, and a plus b becomes a squared minus b squared, which means upstairs we get 2x plus h plus 1, subtract 2x plus 1. See, parentheses still being your friend. Downstairs h, and then you have all the stuff left over. Okay, now you only need to multiply where it helps. Where it doesn't help, don't multiply. So that's why I didn't distribute that h downstairs. All right, so let's make some notes. What's happening upstairs? Well, we have really 2x plus 2h plus 1 minus 2x minus 1. And we're like, whoa, that's so cool. Well, why do we say that? Because we say, hey, check it out. Check it out. The 2x's cancel. The 1's cancel. So what's left? 2h. But what happens then? The h's cancel. All right, so what's really left? Well, what's really left is after we've done all our canceling, this is the limit as h goes to 0 of just 2 over square root 2x plus h plus 1 plus square root 2x plus 1. And see, we canceled the h's. We got rid of that 0 over 0, so we can now plug in h equals 0. Upstairs we get a 2, downstairs we get a square root 2x plus 1 plus square root 2x plus 1. So it's like we have 2 of them downstairs, 1 of them upstairs, so that's like 1 over square root 2x plus 1. Right, because there's 2 of them downstairs, there's 2 upstairs, life is good. Now, this is not our answer. However, we've done all the hard work. This says for any choice of x, now you plug it in, you'll find the derivative. So we say, all right, great, here we go. What do we want? We want f prime of 4. Well, what is it? It's 1 over the square root 2 times 4 plus 1. 1 over square root 2 times 4 is 8 plus 1 is 9. Square root of 9 is 3. Great. We want f prime of 12. Well, that's 1 over square root 2 times 12 plus 1. That's 1 over square root 24 plus 1, 25, which is 1/5. And there we go. We're done. Since we used the limit definition, now we can plug in any choice for x, and life is good. Whew. Nice! Really, really nice. All right, great. Next one. Find the equation for the tangent line to the graph of the derivative of f of x equals e to the 4x minus e to the 2x plus e to the x minus e to the 3x at x equals 0. Now, notice what we're after. We're after a tangent line, but they decided to make it complicated. Why? I don't know. Because do we look for the tangent line to this function? No! We want to take the derivative of that function and then do a tangent line to that. So what we're going to do is we're going to introduce a new function. So let's let g of x be the derivative of this function, f prime of x. So let's go through. Derivative of e to the 4x, 4e to the 4x. Derivative of e to the 2x, 2e to the 2x. Derivative of e to the x, e to the x. Derivative of minus e to the minus 3x is plus 3e to the minus 3x. Now, what are we doing here? Chain rule, right? Derivative of the inside is 4, so that's where that 4 is coming from. Like it's e to the function times root of the function, e to the function times root of the function, so forth and so on. Okay, now, remember, what's our mantra? If we're looking for a tangent line, really what it says is that you have two pieces of information. So if I have a tangent line, I really have two things, namely the function at 0 and the derivative of the function at 0. So give me a tangent line, I can tell you those numbers. Give me those numbers, I can tell you the tangent line. So we got to figure out these numbers. So we say, all right, no worries. We have g of x, so we plug stuff in. All right, well, let's plug in 0. So we have that g of 0. Now, e to the 0 is 1. So we're going to get 4 minus 2 plus 1 plus 3. Well, that's 4 minus 2 is 2, plus 1 is 3, plus 3 makes 6. Okay, that's g of 0. Now, g prime of x. We have to take another derivative because we're after the derivative of g, not the derivative of f, the derivative of g. That's why it's got to keep track. All right, 16 e to the 4x minus 4 e to the 2x plus e to the x minus 9 e to the minus 3x. All right, so g prime is 0. Plug in 0. What do you have? 16 minus 4 plus 1 minus 9. All right, so that's going to be 16 minus 4 is 12, plus 1 is 13. 13 minus 9 is 4. All right, so we now have our value of the function, and we have our value of the derivative. So what does our tangent line become? Well, it's going to become, in general, y minus the value of the function is equal to the value of the derivative, x minus 0. And this is, usually it's x minus a, but a is 0. So for us, we have, okay, y minus 6 equals 4x minus 0, or y equals 4x plus 6. And there we go. Nice! Woohoo! Yeah! All right. Number 5. Let the function f of x be defined by piecewise. It's 1 plus e to the 5x cosine x if we're less than or equal to 0, and 2 minus ax over 3x squared plus x plus 1 if we're bigger than 0. So we have two pieces and we're gluing them together. Now, part A. Is f of x continuous at x equals 0? Use limits to support your answer. Now, you see how they say use limits to support your answer? What does that mean? We better use limits. And if we don't use limits, we're going to miss out on points. We don't want that. We love our points. Okay, so what do we need to check? Well, technically, what we need to check is we have to say, well, what's happening? So does the limit as x approaches 0 of f of x, does it equal f of 0? Now, when you plug in f of 0, what do you have? Well, you plug into this definition. F of 0 is 1 plus 1 times cosine of 0. That's 2. So this is, I'm going to put this as a question mark. Now this right here, just for reference, this is the definition of continuity, but the real issue here, that's not really what we have to focus on. What they really care about, because we have an equality here, what they really are asking for is to say, hey, we want the limit, and because it's a piecewise, we have to do it from both sides. X approaches 0 from below, f of x. How does that compare to the limit as x approaches 0 from above of f of x? Well, from below, we use the below definition. All right, so we put that in. We have 1 plus e to the 5x times cosine of x, plug in 0, 1 plus 1 times 1 makes 2. Here, limit as x approaches 0 from above of 2 minus a times x over 3x squared plus x plus 1. Plug in 0. 2 minus 0 upstairs, 0 plus 0 plus 1 downstairs equals 2. So we say yes, the limits on both sides match. So really what the key thing here is we don't want this, that's a jump. We want this. All right, so good. So both one-sided limits match. We'll even add here, one-sided limits match. So continuous. All right, there we go. All right, part B. Find the value of a that makes f of x differentiable at x equals 0. Again, use limits to support your answer. Okay, so more limits. Just when you thought you were done, they pull you back in. All right, so how are we going to use limits to support the answer? Well, the thing here is what does it mean to be differentiable? We already know they connect, but do they connect like this, where there's a kink, or do they connect like this, where it's smooth? We want it to be smooth, right? So what that means is we need to have not just the functions match, that means they come together, the derivatives have to match. So step 1, take derivatives. Now piecewise functions, piecewise derivatives. So we're going to take the derivative of both pieces. Product rule. So we have the derivative of the first, 5e to the 5x times cosine of x, plus, derivative of the first times the second, plus the first, 1 plus e to the 5x times the derivative of the second, and derivative of cosine is negative sign. All right, they're going to check, by the way. Did you have derivative of cosine? Is it negative sign or positive sign? They're going to microscopic. They're going to fine-tooth comb. Okay, that's if we're below 0. I'm not going to claim equality at 0, but I can claim less than. All right, now, quotient rule. Ugh. Okay, fine. You win this time, exam. We're going to do the quotient rule. Okay, so we're going to take the bottom, 3x squared plus x plus 1, times the root of the top, which is negative a, minus the top, 2 minus ax, times the root of the bottom, 6x plus 1, all over the bottom squared. Okay, and that's if x is bigger than 0. Now, do you need to simplify? No, not now, not yet. So there's often the puzzle, do I simplify? And the basic rule of thumb is you simplify if and when it helps you. So for instance, if the instructions are simplify your answer, it helps you because you get more points. Or if you say, oh, I've got to take another derivative, simplify. You should always think about, have I written my function in the simplest way before taking a derivative? Right now, no reason to simplify, so we won't. But if we need to, later on, we'll do it. Okay, so how do limits come into play? Well, we're going to take limits of the derivative. Just like up here, here we go. Up here we took limits of the function. That makes sure things line up. We have to do the same thing but with the derivatives. Limit as x approaches 0 from below, f prime of x, and we'll just plug it in here. All right, so what do we have? We have 5 times e to the 0, which is 1, times cosine of 0, which is 1, plus 1 times sine of 0, which is 0. All right, so that's 5 plus 0, which is 5. We also plug it in as x approaches 0 from above. Okay, of f prime of x. Okay, so let's plug in 0. It's easier to plug in and simplify than to simplify and then plug in. So we're going to just plug in. Okay, so here we go. 0 plus 0 plus 1. 1. Negative a minus a minus 2 minus 0. So that's 2. 0 plus 1. That's 1. Downstairs, 0 plus 0 plus 1 squared. All right, well that's minus a and minus 2. Now, remember what we said? We want these to match. Okay, so 5 has to equal minus a minus 2, or you move the terms around, a has to equal minus 5 minus 2, which is negative 7. And there we go. Woohoo! Nice. All right, so remember, differentiability, functions match, plus derivatives match, right? You got to line it up, and you got to make sure that your slopes match. So everything's nice and smooth. All right, number 6. Nice. A gymnast throws a ball vertically into the air. And then they catch it. Okay, good job. The height of the ball in meters above the ground is given by minus t squared plus 4t plus 3/2, where the time t is measured in seconds. Answer the following questions. And all final answers should be integers. Now, by the way, whenever you see all final answers should be integers, that's telling you that the answers are going to be nice. They're not going to be like, oh, square root of 22. No. They're going to be like 4, right? So we should have nice answers. Or fully reduced fractions? Yeah. Okay, but usually things should be nice. Okay, include units. Here's the thing about units. Put them in at the end. Units do what you think they should do. So don't stress about them in the middle. Put them in at the end. What is the maximum height above the ground that the ball reaches? All right. Now we can answer this using either calculus type tools, or we can answer it using algebra type tools. Well, since we're doing calculus type tools, let's think about what's happening. So first off, what's going to happen to the ball? It's going to go up, and then it's going to go down. All right, not very exciting, but up, then down. So what's capturing the up? Up is when you have your motion is positive. Down is when your motion is negative. So where does the top fall? Aha. The top is going to be when the motion is 0. So, idea. This will happen when our derivative s prime of t is equal to 0. So let's take our derivative. We have derivative of t squared, 2t, don't forget the minus, plus 4 equals 0. And now, okay, well that says what? T equals 2. Now, that's not our answer. Why not? This is a time. We want a height. Okay, so how do we get a height? We plug in. Okay, so s of 2 is minus 2 squared plus 4 times 2 plus 3/2. All right, minus 4 plus 8 plus 3/2. Minus 4 plus 8 is 4. So 4 is also known as 8/2 plus 3/2. That's 11/2. And that's a fully reduced fraction. Okay, great. Almost our answer. What do we need? Units. Well, what units do we have? Meters. That's the height. We're looking for a height. So we put 11/2 meters. And there we go. Okay, great. Now, part B. Cool. What is the velocity of the ball when it is caught by the gymnast 3/2 meters above the ground? Oh, okay. Velocity when it's caught by the gymnast at 3/2 meters. So here we go. All right. So we're going to set our position to 3/2. So first off, when do we catch the ball? Well, when does the gymnast catch the ball? 3/2 equals minus t squared plus 4t plus 3/2. All right. Well, you can notice the 3/2 cancels. So that says, oh, 0 has to equal minus t squared plus 4t. Okay. Well, that says what? Well, 0 is equal to minus t minus 4. Well, okay. That gives us 2 times. Times 0 times 4. Well, wait. What is times 0? Times 0, that's our throw. We throw the ball. So that must mean that time 4 is when we catch the ball. Notice, by the way, that our peak is exactly halfway in between when we throw and when we catch. Coincidence? Well, not really, but there's a story to tell, and that's more of a physics story. All right, so what do? We're after velocity. We found a time. What do we do with this time? We plug it into the derivative. Now, do we have the derivative? Well, we kind of do, but we mostly erase it. So we'll just write it down again. S prime of t minus 2t plus 4. So S prime of 4, that would be minus 2 times 4 plus 4, which is minus 8 plus 4, which is negative 4. All right. Now, units. Distance is meters. Time is seconds. So the velocity is output over input, right? The output of S is a height, it's meters, input is t in seconds. So it's negative 4 meters per second. Now, quick question. Do we include the negative 4? I mean, I already put a box around it, so that's probably a clue. Yeah, you probably should include it. Why do we include negative 4? Because it's asking for a velocity, not speed. Velocity has sign. Plus means something. Now, plus means you're going to the right. Minus, you're going to the left. And so, or in this case, plus means you're going up. Minus means you're going down. So if you're after velocity, sign makes a difference. So if you said, and your answer is, oh, it's 4 meters per second, well, farewell 1 point, you know. But we're not going to say goodbye. We're going to get all the points. That's right. We're going to go all the way. Woohoo! Yeah!